Radiation is the mode of heat transfer which does not require a material medium for its propagation. Heat radiation or thermal radiation from the sun reach the earth by this mode of heat transfer. Thermal radiations are electromagnetic waves which travel with speed of light, that is 3 to 10 raised to 8 meter per second. Next is black body radiation. Black or dark colors absorb all heat radiations falling on it. So we consider bodies that absorb or emit heat radiations as black bodies. Black body absorb all radiations falling on it at all temperature. It also emits maximum radiations as compared to other bodies. We consider sun, stars as black bodies. Lamed black surface is an example of a black body. Wein's displacement law. Here we have a graph of black body emission intensity along the y-axis, that is amount of heat radiated per unit area per second against wavelength of the radiations emitted from the black body when it is heated. Consider a black body at temperature T1. We can see that it emits a lot of radiations of different wavelength, but radiation of a particular wavelength lambda m1 is maximum. If we consider another black body at temperature T2, here also we can see that it emits a lot of radiations of different wavelength, but radiation of a particular wavelength lambda m2 is emitted most. Similar is the case with a black body with temperature T3. Here also we have a lot of radiations of different wavelength, but radiations of wavelength lambda m3 is emitted more compared to others. Similar is the case with another black body at a higher temperature T4. The T4 is greater than T3. We can see that as temperature increases, lambda m shifts towards the low wavelength side, that is lambda m1 is greater compared to lambda m2. At a particular temperature, the intensity of radiations of a particular wavelength lambda m emitted from the black body will be maximum. As temperature of the hot body increases, the value of lambda m moves to lower wavelength side, that is lambda m is inversely proportional to temperature, or lambda m into T equal to a constant. Lambda m into T is equal to 2.9 to 10 raised to minus 3 meter Kelvin. So here we are going to use Wein's displacement law in this problem. The wavelength of a maximum solar emission is observed to be 0.47 micrometer. What's the surface temperature of the sun? We use Wein's displacement law to find the temperature of celestial bodies if we know lambda m. Lambda m is 0.47 micrometer here, that is 0.47 into 10 raised to minus 6 meter. We can substitute in this equation, that is T is equal to 2.9 to 10 raised to minus 3 by lambda m. 2.9 to 10 raised to minus 3 by 0.47 into 10 raised to minus 6. We get 6105 Kelvin.